Hello, it's me here. So yesterday the first SWOT satellite successfully launched from the French spaceport in Kourou, French Guiana. The mission is a joint venture between NASA and CNES, the French National Centre for Space Studies, with contributions from the Canadian Space Agency and the UK Space Agency. Today, we're going to take a look at what SWOT is all about and how these different agencies around the world contributed to this very cool looking satellite. So SWOT stands for the Surface Water and Ocean Topography SWOT mission. It is designed to map the surface topography of the Earth's oceans in large lakes and rivers with unprecedented accuracy, which will allow scientists to study how water moves around the planet and better understand our planet's water cycle. We have looked at ocean surface height before, but SWOT will do it with a resolution that is more than 10 times higher than previous missions, which is pretty incredible. The satellite was jointly developed by NASA and CNES. NASA JPL manages the U.S. component of the project for the agency by Caltech in Pasadena, California. So the U.S. provided the QA band radar interferometer called CARIN, a GPS science receiver, a laser retroreflector, a 2-beam microwave radiometer, and NASA instrument operations. CNES provided the Doppler orbitography and radio position integrated by satellite system, the dual-frequency Poseidon Alpha, the Korean radio frequency subsystem together with Thales Alenia Space, and with support from the UK Space Agency, the satellite platform and ground operations. The Canadian Space Agency contributed the CARIN high-power transmitter assembly. This is the first time that 3 space agencies have come together with one satellite. It is also the first ever to use the new European Vega C launch vehicle. So how does a satellite like this work? SWOT is equipped with an advanced radar that uses an innovative technique called a synthetic aperture to create incredibly detailed images of Earth's surface. Basically, this means that instead of taking pictures from directly above, the radar sends out beams at a very low angle and then uses motion to create an image. By moving along a path, the radar can synthesize a much larger aperture than if it was just sitting still. This allows SWOT to measure the height of ocean surfaces down to 20 centimeters, or about 8 inches, and it can do this over a swath that is 600 kilometers, or 370 miles wide. SWOT will cover nearly the entire accessible ocean surface during its mission, collecting data on everything from the height of ocean waves to the shape of underwater mountains. This level of detail is unprecedented, and NOAA allows scientists to study our oceans like never before. The mission will also be supported by various other instruments, including a GPS receiver and a laser which will allow us to precisely track the satellite's orbit and position, and a microwave radiometer, which will measure the temperature of the ocean surface. One of the most exciting things about the SWOT mission is the potential for discovery. Scientists are hoping to use the data collected by the satellite to study a wide range of phenomena, including ocean currents, tides, waves, and sea level rise. They will also be able to measure changes in the height of rivers and lakes over time. This could help us better understand the impact of climate change on our planet's water resources. SWOT will be launched into a sun-synchronous orbit, which means that it will pass over the equator from north to south at the same local time every day. This will allow the satellite to collect data on a wide range of different locations around the globe. But wait, there's more. SWOT isn't just a one-off mission. It is actually the first of a new series of Earth-observing satellites that are being developed by NASA and CNES. The next satellite in the series will be the Surface Water and Ocean Topography Follow-On, which will continue to monitor changes in our planet's water resources. The SWOT mission is truly an amazing example of international cooperation in space exploration. It's a testament to what can be achieved when different nations come together and pool their resources. The data that is collected by the mission will be freely available to scientists around the world, which means that researchers everywhere will have the opportunity to make new discoveries and push the boundaries of our understanding. The collaboration between NASA and CNES on this mission has been going on for many years, and it has resulted in a truly innovative and exciting project. So now let's talk about the role of the different organizations that are involved in the mission. NASA has been a key player in the development of SWOT, providing a significant portion of the funding for the project. They have also provided some of the key instruments that will be used on the mission, including the Ka-band radar interferometer, which is one of the most sophisticated pieces of equipment on the satellite. In addition to providing funding and equipment, NASA has also provided expertise in areas such as data processing and analysis. NASA's Jet Propulsion Laboratory, or JPL, is a world-leading center for research and development in areas such as radar, remote sensing, and oceanography. This expertise is essential for the success of the SWOT mission. CNES, the French National Centre for Space Studies, is the other major player in the development of SWOT. CNES is responsible for providing the overall leadership for the mission, as well as providing the satellite platform and ground operations. CNES is also working closely with NASA to ensure that the two agencies' instruments and systems are integrated properly on the satellite. The Canadian Space Agency, or CSA, is contributing the high-power transmitter assembly for the Corinne instrument. The CSA has expertise in the area of microwave radio frequency systems, and this expertise is essential for the success of the Corinne instrument. The UK Space Agency is providing support to the mission in the form of funding and expertise. The UK Space Agency has expertise in areas such as mission operations and data handling, which is essential for the successful implementation of SWOT. The SWOT mission is a truly ambitious project that will require the expertise and cooperation of all of the organizations involved. The success of the mission will not only advance our understanding of our planet's water resources, but it will also demonstrate the power of international cooperation in space exploration. As the SWOT mission gets underway, we can expect to see a flurry of activity as the different organizations involved work together to launch and operate this incredible satellite. The launch of SWOT is a momentous occasion, and we can all look forward to the incredible discoveries that this mission will bring. So there you have it, a summary of the SWOT satellite mission. Let us know what you think about this mission in the comments below. Do you think it will be successful? What do you think it will teach us? And do you think there should be more international cooperation in space exploration? Don't forget to subscribe if you want to learn more about space exploration. We will see you next time.